Hello everyone. Welcome to yet another video in the machine learning course, where we will discuss about the cost function of logistic regression. So I will try to continue the previous part only, where if you remember in the last session I have shown you with the help of one mathematical derivation that how when the probability is lesser than, let's say, zero point 0.5, maybe it's a zero point 0.2 for class 0 and zero point 0.8 for class 1 automatically, how with the help of that formula of logarithmic, which is log base e in brackets sigma of y cap divided by 1 minus sigma of y cap, which is a sigmoid function, is equals to mx plus c, we reach to that derivation. So we have seen that it would become negative in the case when the class value is zero point 0.2 for the probability of class 0 and zero point 0.8 for the probability of class 1. It is more than positive quantity. So everything I have covered up in the last session. So if you're not aware what I am saying right now, please do refer again the last video. Now in this particular session, let's try to discuss that what is the cost function. So we have seen that, okay, how binary classification in a logistic regression internally happens. That is completely fine. That scenario is okay. But how internally the cost function will work in a logistic regression, is that same as that we have covered up in a linear regression, that is a mean squared error, if you remember, or is it something different? And if yes, why is that so? Why that MSC is not working here? So everything and anything we will try to discuss in this particular part of the video. So let's get started. So always remember that the cost function of logistic regression algorithm is a log loss. It's a logarithmic loss function, you will observe. And this is defined as below. So here you can see I have mentioned h theta of x comma y. So this h theta indicates the prediction which is given by my model, as it's a binary classification task. So it can be either 0 or 1. And y indicates the actual label data. So it indicates the actual data. So predicted one and actual one. Now what we have mentioned, that let's say the actual is 1. Let's consider one simple problem. For example, I will give you one simple example, and I think with the help of which you will be able to clearly understand what I'm trying to convey here. For example, we are dealing with a problem in healthcare domain where we want to do analysis that whether a patient is diabetic or not. So the situation is, we want to make a prediction that either the patient is diabetic, so it belongs to class 1, or the patient is non-diabetic, means it belongs to class 0. And let me tell you, I will try to continue this story in order to explain the upcoming concepts of the videos, where I will demonstrate you the practical implementation. We will try to pick up the similar kind of a data for the classification task, as well as when I will try to show you the confusion matrix, where I will try to demonstrate the accuracy, the concept of precision, F1 score. At that point of time also, I will pick up the same example so that we all are in a sync. That's the only reason. Okay? So what I'm saying is, let's say we have a problem statement where we need to predict that whether a patient will be a diabetic patient or a patient will not be a diabetic one. So either he or she belongs to class 1 or he or she belongs to class 0, depending upon whatever number of features we have. So what I'm saying is, as per my cost function, this is my value of y. This is my value of y. Okay? Now what is this h theta of x? This is the value which is made by the predictions of the model, where we will apply this logistic regression model. Okay, so now let's say I'm saying ki the actual data or feature set demonstrates that a patient is diabetic. Okay, so what I'm saying is that actually in an actual case patient is diabetic, means the value of y is equals to 1. That is the actual use case, that is the actual scenario. Now maybe you can say ki prediction says, after applying a logistic regression, prediction says that the value of y is equals to 0. Now let's first of all take a good example where we are saying, a best case scenario where we are saying that y cap is also 1, where the value of y cap means the prediction is also 1. In that case, you only tell me when I will do negative of log of 1, what is the answer? So I think you all know logarithmic of 1 is infinite. Log of 1 is 0. So now what you will be able to get as an answer is the value will be approximately equals to 0. And that is what ultimate thing we want. What does this cost function says? It's nothing but error value. That's why it is also called as error function, error rate, anything you can say. So what it indicates that when the predicted and the actual both are same, our error is 0, which does make sense. I hope you can clearly able to understand what I'm trying to convey here. Let's take another example. Let's take the example of when the patient is not diabetic. So actual cases कि patient is not diabetic. Actual cases that patient is not diabetic means the value of y is 0. And prediction also says, which is the value of y cap, that patient is not diabetic. It's again a good case, right? It's again a best case. So all these are the best cases as of now, which I'm demonstrating you, just to show you how the above cost function is working perfectly fine internally in case of a logistic regression algorithm. Okay? Now, when you are saying that the value of y is 0, means patient is not diabetic, and my algorithm is also predicting that the patient is not diabetic, means the value of y cap is also 0. So, by the way, when I'm saying y cap or when I'm saying h theta, this is one and the same thing, h theta of x. This is one and the same thing. So, in few websites, you will observe that they are using y cap, which is equals to mx plus c. Especially in my last video, I have taken this particular equation and then I have tried to solve this equation on top of a sigmoid function. I hope you all remember. But in standard websites and even in standard books, you will observe that the equation which they are referring is h theta of x, which is equals to theta 0 plus theta 1 of x. So it is c, it is m, one and the same thing, means this is a slope only which they are referring, and this is the, intercept only which they are referring. So don't get confused within the equations. Equations are same only, the way to represent them is different. So it might be the case that you will observe that in few scenarios, with respect to some standard websites, they're writing this kind of a equation of theta 0 and theta 1. So I might also use in my courses sometimes, but don't get confused, okay? All these two equations, this is the equation number 1 and this is the equation number 2, they both are same, signifies the similar sense. So when I'm saying y cap is equals to 0, so prediction says that, okay, patient is also not diabetic, right? Now let's move back and let's try to solve this. Negative of log of 1 minus 0. Now again, what we are getting? Log 1 is 0. So again, approximately our error value is also 0. So this is the best case scenario where our actual data and the predicted data exactly matches. But you know that it's an ideal case scenario, and in practical terms, when we are dealing with the real time data, the chances of this can be good, but it cannot be 100%, right? There will be definitely an error which will come when we deploy our model. So what is the worst case scenario? Let's try to understand that part now. Now, I hope everyone knows the worst case scenario could be where the, actual case and the predicted one doesn't match. That is something which we will say as a worst case, right? So what does that indicate? Let's say in the actual part, in the actual case, a patient is diabetic. So you are saying that the value of y is equals to 1. Perfect. But let's say you have tried to do a model training and after that prediction says that a patient is not diabetic. The value of y cap is equals to 0. That is where I'm calling it as a worst case scenario. Now see what will happen. If you will try to understand this point, just try to see negative of log of your prediction says the value is 0. It's not equal to the actual value. And log of 0 is now infinite. So it is approaching towards infinite, means your error value, your error rate is approaching towards infinite. So in this case, if you will be able to understand, your error value is approaching towards 0. Your error value is approaching towards 0. The only reason could be that the actual and the predictions both are same. But in this case, your error value is approaching towards infinite. That is what you need to observe. Now, let's move to the next scenario where, let's say, your actual data says that a patient is not diabetic. The value of y is equals to 0. But somehow you have trained your model and your prediction says that your value of y cap is equals to maybe 1. Again, vice versa. It is not matching to the actual prediction, that actual value that we have, right? So now let's again try to understand what is the output we will be able to get. Try to apply the same equation. Because the value of y is 0, so we have to use the second equation. 1 minus, what is the prediction? It is also 1. So it will be 0. So again, you reach to a negative of log 0, which is equals to infinite. So yes, in this case also, you will observe that your error booms up to infinite value. So in the best case, your error value will be approximately equal to 0. And the worst case, your error value will be reaching towards a infinite. So it is going very, very high. And that is what we are doing, right? At the end of the day, when we are training our model, our goal should be to reduce the error value, right, as much as we can by doing training multiple times, so that we will be able to reach to a point where the error will be minimum. Now the question may come, so this is the final, first of all, cost function which we may have for the logistic regression. It is usually asked in a lot of interviews as well. Sometimes you will see that people usually combine these two equations in one go, and the cost function will look like something like this. So cost function of h theta, comma, the next value h theta of x, comma y, h theta of x, comma y. It can be, you can see in some books will look like this. Negative of yi, log of h theta of xi. Log of h theta of xi minus 1 minus yi. Then it will be 1 minus, I think, log of 1 minus h theta of xi. So what I have done is, I have just combined the above two equations in one go. So that is the only thing which basically I have done here. So I have simply combined above two equations, and this is the net, I would say, cost function which we will be able to get, where you can see this yi indicates the probability, or you can say actual value, actual data of one class, and this is obviously the actual data or label of another class, right? Another class data, or you can say label of one class and another class. So basically what you have done, you have just combined these two equations. So let's say at any point of time, either your value of yi will be 1 or 0. So accordingly, let's say your value of yi will be 1. So if it is 1, automatically this complete equation will become 0. And if let's say your value of yi will be 0, then in that case, your value of this part will automatically become 0. So in a way, you have done to make this combination look better. And that's why what you have done, you have just combined these two equations. If you want, you can write in a above manner also. If you want, you can write in a one go also. Why I have shown you? Because again, in many websites, in many standard books, you will observe this kind of a equation. So again, don't get confused that I have never ever saw this equation. What is this all about? This is the predictions. This is the predictions, right, of the models that we have. That's it. Simple. Now, the question which can come in any one of your head is that, Priya, in the linear regression, we are working with a MSE, right? Mean squared error. So why can't in logistic regression you can do the similar kind of a thing? What is mean squared error? If you remember, we have tried to apply. So I am just telling you just to have your idea ki why MSE is not working in logistic regression and why we are going for this log loss or logarithmic based cost function in logistic regression. So let me just give you a brief idea that what usually happens is ki when we are talking about mean squared error, it is 1 by 2m summation. If you remember, it will be sigma of I, right? Sigma of I minus yi whole square, right? This is something which we have as a value of, you can say, mean squared error, 1 by 2m. So I is equals to 1 to m. Now, specifically, it's a sigmoid function in case of a logistic regression. So y MSC not, suitable, or you can say working, I would say suitable for logistic regression algorithm. That is the reason which I am trying to give you in terms of mathematical intuition, because this is also very important to understand. It's fine, many people usually cram ki theek hai, in a linear regression we have MSE for the error function per se, for the cost function per se, and for logistic regression we will always go for the next important thing, which is the log loss cost function. But the question which you should ask from yourself is, why is that so? What is the intuition behind that? So I'm giving you that intuition, which might be helpful to you to understand. But by saying that, you should have a brief idea about mathematical part. I will give you an intuition, but now further you can explore by doing your own research. So what usually happens, it's a sigmoid function, right? It's a sigmoid function in a logistic regression. Now, let's try to fill that value. You will be able to understand summation of I equals to 1 to m. And here you will be able to get 1 divided by 1 plus e to the power minus z, which is equals to theta 0 plus theta 1x. I think I have tried to solve this complete derivation in the previous video as well. Minus y of I whole square. This is something which we have, right? 1 by 2m. After that, summation of I equals to 1 to m. Sigma of I have tried to place this value, which is 1 divided by 1 plus e to the power minus z, and z is nothing but theta 0 plus theta 1x, minus yi square, which is the actual data. This is what we have in case of a linear regression. Yes, the only difference is in linear regression, we are directly writing it as theta 0 plus theta 1x, or you can say mx plus c, one and the same thing. I'm again repeating, both of them are the same equations. So in this case, we are not directly writing this line, we're using a sigmoid function. That's the only difference. Now, if you will try to solve this derivation, just like the way I have done in the previous class, previous part of the video, you will observe that when you will try to do a plotting of this curve, you will get a non-convex curve. Now, what is the meaning of a convex curve and what is the meaning of a non-convex curve? Convex curve meaning where you will be having, so when I'm saying convex curve in mathematics, the simple meaning is that we will be having a single local and global minima. That is the literal intuition behind the convex curve. For example, we have talked about gradient descent in linear regression algorithm, where we have seen how the updates of m and c, or theta 0 or theta 1, helps us to go to the global minima. We are starting with our error rate from here and we want to reach there. So this is a kind of a curve which is a convex curve, where we just have a single global minima as well as local minima also. Now, when you are saying when I'm saying this MSC of logistic regression, when we try to solve, we will get a non-convex curve. Simple literal meaning is, in a layman fashion, if I'll try to explain you, that here we will be having a multiple local minima, right? We will be able to have a multiple local minima, which basically gives me a very difficulty, or my model's very difficulty to optimize. So there is a lot of difficulty in terms of optimization. What is the simple meaning? Let me try to again show you. Let's say we will be having a curve like this, right? In this kind of a curve, we have so many local minimas, like this, like this, like this, like this, like this, like this. This is where I want to avoid this. This is where my model will get the difficulty in order to get the optimized value, in order to get the minimum, error rate, in order to get the minimum cost function value. So this is the cost function that we have, and this is the theta value that we have. Again, same thing here as well. So this is the cost function. So in linear regression, when we are trying to solve via MSE, so we got this kind of a curve, and that's why traditional gradient descent algorithm that we have used in our explanation in the previous module works perfectly well. So it is suitable, traditional gradient descent is suitable for a concept of linear regression, right? That's why it is suitable. But when I'm saying in the logistic regression, because the sigmoid function came into picture, it creates a non-linearity transformation. It creates a sense where I will be having multiple local minima. That's why not suitable for this particular logistic regression. Traditional gradient descent algorithms are not suitable. Traditional gradient descent algorithms are not suitable, right? Maybe some words either either, but I hope you will be able to understand what I'm trying to convey. So that is the only reason that why we went to the above log lowest cost function in case of a logistic regression. So I hope that now the intuition behind this is pretty much clear. So what I have covered up, I'm again wrapping up in a nutshell. We have understood basically what is the cost function in terms of a splits. First of all, I have shown you. I have also talked about how the intuition varies when we will be having a best case scenario and then when we will be having a worst case scenario. After that, I have shown you that in some standard books, you will get the combination of two equations. Don't get afraid with respect to that part. At the end, I have shown you in this video that why MSC is not suitable for logistic regression. Just like the way we have done in linear regression, what's the issue in this case? That is what I have tried to convey to you. So now I hope that you will be easily able to understand the complete concept and idea behind the cost function of logistic regression. I'll see you all in another video where now we will discuss the practical implementation of whatever things we have covered up so far in a logistic regression algorithm. So I'll see you all in the next video. Bye-bye and take care. Hello everyone. Welcome to the new video where we will discuss further with respect to the logistic regression part. If you remember in the last session, we have had a great discussion about, the cost function of logistic regression algorithm. In this video, I told you that we will plan to have a end-to-end project pipeline where we will do each and everything from scratch, and we'll try to implement the logistic regression algorithm. But before that, I think there is a need where we should discuss about the model evaluation matrix also. So just like in linear regression, we have seen that, RMSE or, MSE is a great evaluation metric to check that whether the model is properly doing a regression task or not. Similar to that aspect, we need to carefully verify that whenever we are doing a classification task, does that doing a appropriate manner or not with the help of a confusion matrix. So yes, in today's video we will have a major focus on the confusion matrix, with the help of which you will be able to understand multiple evaluation metrics in one go. For example, accuracy, for example, recall, for example, precision, for example, F1 score. So without wasting any time, let's get started with that concept. So now, whenever we are discussing about this confusion matrix, first of all, let's try to understand why it is called as a matrix. So basically, we will try to create here 2 cross 2 matrix today. And I'll try to demonstrate you everything with the help of the previous use case itself. I hope you all remember. In the last session, while discussing about the cost function, I have demonstrated you one use case of diabetes prediction. Do you remember that? So we will try to take that same use case, and with the help of that, we will try to understand the complete idea about this confusion matrix. Let me tell you, this is one of the confusing topic for many of the learners. And if you will try to pay attention till the very end of the today's video, you will be able to get a better understanding of the same. So let's try to understand how this matrix will looks like. So you have observed in the previous session in the cost function that we will be having definitely 2 values. As it's a supervised learning, so we do have actual values available with us. And then let's say we are applying any of the classification algorithm. So we will be able to get the predicted values as well. Make sense? Now, by the way, whatever things I'm teaching you in this video, it's not specific to logistic regression. It is applicable for all the classification algorithms that we have in machine learning. So please make sure that you will understand this concept in a great detail so that it will be beneficial for all the upcoming classification algorithms. So what I'm saying is, this evaluation matrix that we are discussing today is applicable for all the classification kind of a problem. Classification problems. Okay? So it is not specific to logistic regression. You can apply the similar knowledge to other classification algorithms that we will discuss in the upcoming part of the course. Now you know that either our actual value will be 0 or 1, because as of now we are dealing with a binary classification task, right? And it's a binary. When it's a binary classification, we are either having a value as 0 or we are having a value as 1. Or in other words, I can say either the value is positive or the value could be negative, right? Similarly, prediction is also either positive or negative. So I can write the same thing here as well. So either it will be positive or it will be negative. I hope you all are agree with me. Now, this is a kind of a 2 cross 2 matrix, which you will be able to see now on my screen. Now, this is where actual concept will come into picture. And please pay attention how basically I'm writing these terms. See, what I'm saying is कि actual value is positive, means let's say the value of y is equal to 1, right? Meaning that a person is diabetic. I have an actual record where it is displaying at the target value, at the outcome value, that the person is actually diabetic. And my prediction, when I applied the formula of, let's say, cost function of a logistic regression algorithm, or maybe anything, but as of now, because we have just discussed logistic regression in our course, so let me take that example only, that I have applied that logistic regression algorithm, and that model gave me a prediction that, the value of y cap is also 1. It's a good case, right? Do you remember the best case scenario? I think this is one of the best case scenario, right? So what you will write you will say this term as true positive. Now, how I have written this true positive? Because my prediction is positive, that's why it is positive. And it is true because my actual data is also positive. In short form, you will observe in many of the standard websites and books, you will see as TP. Full form is true positive. Let's move to the next block. I'm moving it diagonally here. Same thing, it's also best case scenario where actually your data says ki a person is not diabetic, means the value of y is 0. And prediction by the model is also saying that the value of y cap is 0. 0. It's again a best case scenario, right? But what is your prediction here? Negative. So you will say it's a case of true negative. It's a case of true negative, which will be represented as Tn here. Tn here. I hope so far so good. Now let's move ahead to the filling of the remaining two blocks that we have. Now this is important. What you are saying is that actually the patient is not diabetic, with the value of y is 0. But my prediction says the value of y cap says he or she is diabetic. Now that is where error will come. That is where the worst case scenario will come. But what is your prediction says? It's positive. It's positive. Your prediction says it's positive. But is that a true positive or a false positive? It's a false positive, right? It's a false positive. So it will be represented by FP. So how I have written, again I am showing you. Please try to understand it very carefully. So what I am saying is, my prediction says that the patient is diabetic. But actually the patient is not diabetic. The value of y is 0. That is why we are saying the record is positive because the prediction is positive, but it's a false positive. Now let's focus here. Now you can just pause the video and let me know what this particular block you will call as. Prediction is negative. But if you can see, actually patient is diabetic, but you have applied logistic regression algorithm here. And because of that, you will be able to get an idea that your model is saying that patient is not diabetic. So it means that my prediction is negative, but this is something which we can say is a false negative, which is denoted by Fn. So these are the 4 blocks in a confusion matrix, and with the help of which you will be able to get the complete intuition behind the different evaluation metrics that we have. For example, first of all, I would again suggest you just pause the video and check, is this point is clear? What is true positive? What is true negative? What is false positive? What is false negative? Always when you're filling this table, check what is the prediction is all about. And then once, whether it is positive or negative, after writing that, check is that true or false. If it is true, then it will become true positive. If it is false, then it will become false positive, and so on. Now, with the help of this confusion matrix, we will be able to evaluate different model evaluation things. For example, if let's say someone will say, what is the meaning of accuracy? So accuracy is nothing but is equals to how much total positivity is there. So it is nothing but what is the true positive value plus negative value. It is something which is correct, right? Divide by total 4 terms. True positive, false negative, plus true negative. So this is the first thing which we can evaluate very easily, which is accuracy. Second evaluation matrix will be recall. What is recall? Recall says that out of actual true positive, how much or how many, in case of this actual positives, how many of them are true positives? So if you can see, the first column of positive indicates an actual positive. So what recall says that out of total, I would say, actual positives, out of total actual positives means true positive plus false negative, because this first column indicates total actual positives. How many of are true positive? So this is the literal meaning. So it will be TP divided by TP plus Fn. Another thing is something which we call as specificity, which will take care of true negatives. So it will say specificity. It will say out of total true negative. So out of total actual negatives, how many of them are true negative? So it will focus on the next column that we have. So how many of our actual true negatives? So it will be Tn divided by, you will see Tn plus Fp. Tn plus Fp. So here it is sum of actual positives that we have, and here it is sum of actual negatives we have. So actual positives, and here it is actual negatives. So I think so far things will be pretty much clear to everyone. Now, next important term that we have is precision. Apart from these three terms, precision, another evaluation matrix in a classification part, which basically takes care कि out of total predicted positives, when I'm saying out of total predicted positives, it means that somehow I'm referring the row part now. I'm referring the row part now because predicted value is a row part, right? How many of them are actually true positive? So what I'm saying is that precision is TP divided by TP plus, I would say, FP. So this is the sum of, I would say, predicted positives, right? Sum of predicted positives. So out of the given predicted positives, how many of are actually true positives? This is given by the indication of precision. So all these are the different evaluation metrics that we have depending upon different circumstances, different use case. We prefer to go for different types of evaluation metrics that we have. For example, let me again give you one simple example. This is again one of the most important interview question. People can ask you that out of precision and recall, let's say we are talking about a use case of diabetes prediction, right? Diabetic prediction. Or maybe I would say any healthcare use case. Any healthcare use case, right? In this case, if you will be able to observe, we have seen that we have, let's say we are comparing two evaluation metrics. One is recall, one is precision, right? So the precision says it will be TP divided by TP plus FP. Recall says it will be TP divided by TP plus Fn. I hope you all remember, right? Now, if let's say I will say ki with respect to this healthcare analysis, with respect to this diabetic prediction, which one is I would take care in a better manner. So if you can see in the recall, recall will be higher when the below term will be lower. It means somehow I need to reduce this value of Fn, right? What is the meaning of false negative? False negative meaning will be, let me just remove all these things so that the confusion will be very less. False negative will be where actually patient is diabetic, but my model is saying that he or she is not diabetic. That's a very worst case scenario with respect to healthcare domain. So always remember, in case of any healthcare problem, our target is always to reduce this particular error, this particular false negative term. Or in other words, I can say, I will always take recall as a, important evaluation metrics, as a important, I would say, evaluation metric specifically for the healthcare person. Why I'm saying so? Because this situation is very dangerous as comparable to the another type of error. Although both the errors are very bad, but if I have to compare this Fn and Fp, I would say Fn is more dangerous because in this case, patient is genuinely having some problem, some issue is there, some healthcare issue is there, but my model is saying he or she is fit. That's a dangerous problem as comparable to this one, where my patient is fit. Let's say patient is not having a diabetic issue, but my model is saying that he or she does have, right? Maybe he will take care more about their health and everything. It's a better as comparable to the another situation, right? Although again I am saying our major target is to reduce both of them, FP as well as Fn. But specifically for healthcare, if someone will ask you that which particular evaluation metrics you will choose as a priority, your answer will always be it will be recall. Because precision will take care of FP. You have to reduce the FP in order to increase the value of the precision. But specifically for healthcare, the good evaluation metric will be recall as comparable to precision. But let's say now I will give you one situation, one problem, and you can just let me know after understanding the concept pretty well that let's say we will be having a issue of spam classification. So I hope you all know that in our mails also there is algorithm which is internally going on, which specifically identifies that whether a mail is important or it's a spam mail. Accordingly, it will try to classify that point. Now, if I'll ask you this question, that can you tell me, in that case, what do you think? Recall is more on priority as an evaluation matrix, or precision is more on priority as an evaluation matrix? I'm looking forward to your answer. But let me give you the answer. It would be precision. Now, the question is, how is that so? You only think over it and let me know. But the correct answer will be, so if anyone is saying that precision is the one, then he or she is correct. Logically, you have to give me the answer. That then only I can say ki if logic is correct or not. But precision is the one. Why is that so? Think over it. In the upcoming videos, I'll let you know why precision is the one. But in this video, I'm giving you as an assignment. Now, let's move ahead. If let's say in few situations you will say ki Priya, if recall and precision both are equally important, at that point of time we usually have some other metric which is called as F1 score. F1 score, which is the combination of precision and recall, where you will say 2 into precision into recall divided by precision plus recall. So you can see it's a combination of both of them. So if at any point of time you won't be able to decide, or there is any situation, there is any use case where you feel that both of them are equally important, you can always go for this another evaluation matrix, which is a F1 score. Now, as I told you, accuracy, again, it's a reliable thing which you usually evaluate. There are few instances, for example, when our data is imbalanced. What is the meaning of that? The simple meaning is where let's say you will be having for 0 class, maybe let's say I'm giving you one simple example, the people who are not diabetic, let's say we have 1,000 records. But the people who are diabetic, let's say we just have 200 records. This is the meaning of data imbalancing. In that case, definitely accuracy is not a good metric, but in other factors, the accuracy is a better way. Recall, I have already talked about. Specificity to check it out that how many actual negatives are there, right? So all these are the evaluation metrics that we have, which we easily able to compute with the help of this confusion metrics concept, right? When we are doing the implementation, it's very, very easy. From sklearn, we directly import this confusion matrix and we will be able to evaluate all these terms. In the upcoming sessions, when we are doing a project end-to-end, I will show you the complete end-to-end idea that how the implementation will happen. But before that, I request you all to again rewatch this video, make your notes, document it pretty well, and try to understand whatever concepts I have talked about today, whether it with respect to true positives, false negative, true negative, how basically I'm writing this term, that is important to understand. I don't want anyone to cram these stuffs. You have to just understand these concepts in a very logical manner. And after that, how basically accuracy, recall, precision, specificity, and F1 score is evaluated. So now I think that you got a better idea about the confusion matrix, how basically with the help of which we will be able to evaluate multiple evaluation metrics like precision, recall, F1 score, and so on. So I think now it's the right time that in the upcoming video, we will discuss one hands-on project where we will see whatever knowledge we have gained so far with respect to logistic regression. We'll try to implement that. So I'll see you all very soon in the upcoming video.